To Uiua for Absolute Beginners number 3. Here we're going to look at Advent of Code 2018 problem 1. Attacking this problem will actually be split across 2 videos. There'll be a lot of background in this video and a preliminary solution, and then we'll get into some more detail later. But let's just have a quick look at the nature of the problem. So the input gives you some frequency deltas, meaning increase by 1, increase by 6, increasing by 6, increase by 2, and so on. Here's a decrease, a decrease. So these are changes, and from that, if you start at 0, you can easily derive a list of actual frequencies. Problem 1a is to find the final frequency. So that's really easy, you just add everything up. So it is day 1 after all. And problem 1b is to find the first frequency that ever repeats. And the input has about 1,000 deltas, and they're carefully chosen so that none of them ever repeat. And so what you need to do, the problem states that you can use the deltas again and again, so you can keep applying the same data to generate ever more frequencies, and eventually something will repeat. Here's a Python implementation sketched out. So you start with a frequency of 0, you keep a set of every frequency you've ever seen. For delta in, so an endless cycle of the data, that's not built into Python, but you can write it in a couple of lines of code. So if you cycle through the data, you keep track of what frequency you're up to. You if you've seen it before, then you've got the answer. Otherwise, you add that frequency to your set and you continue. Okay, so it's really easy to solve day 1b in most programming languages, but it is, to my limited experience, it's not something that's easy to solve in Uiua. Okay, so now I'm going to get into some coding, and I've got a list here of things that we're going to get through. So let's start. We're going to start with boxing. What does boxing mean? If I say box 5, then I get a box and 5. Well, what does that mean? Well, that's a bit of a weird thing. Here's a motivation for it. If I might have covered this in the first video, if I try to create an array of 2 words high there, then I get a problem. They're not the same length. And Uiua is an array programming language, and arrays can be multi-dimensional, but they have to be consistent in their length. So I can, if I put 3 spaces in there, then no problem, right? But that's obviously not what we really want. If I change the bracket style to braces, now it works. And what it's done is it's boxed up the high and the there, and so I can show that more directly. So box high and box there, I get the same result. So obviously this is a nicer thing to type than this, right? But they mean the same thing. Now, what does it mean? Well, if I ask for, let's say I put the exactly what I had before. Oops. Okay, and if I ask for the shape of that, then I get a 2 and 5, right? So I'll keep a copy of it there. So we've got high there, and it's 2 rows, 5 columns. So it's a 2 by 5 matrix that we've got here. Whereas if I get rid of that, if I ask for the shape of this, well, it's just 2. It's just an array that has 2 things in it. Those things are a little bit opaque, right? It's got 2 boxes in it, right? A box is just a thing, the details of which can be deferred. So that's Uiua's way of getting getting other data, no matter what the shape is, just into a container. It's very good. So that's what boxing is, and we're going to see why that's important. What can you do with something that's boxed? Well, you can unbox it. But if I take this high there, right? So I'll get rid of these two things. If I take that, I can call each length, for instance. So I say it's kind of opaque, but the length function can look inside a box to get the length. So it's kind of semi-transparent. Okay, and what can you do if I take let's say the first of this, and I get a boxed high, and what can you do with that? Well, you can unbox it. And now I've got like an array, right? Let's see what the shape of that is. It's one-dimensional with length 2. Okay, so that's boxing. Let's talk about reading data from a file, because boxing is important here. So if I have a file called called video, and then 3, I'm going to start with words.text. Now, how do I read it? I call the built-in Uiua function FRAS. The ampersand means we're calling a system function. It's just part of the name, but it means it's a system function. And FRAS is short for file read as string. So there we go. I've got a paragraph of Sherlock Holmes novel. And yeah, it's just text, right? And I want to extract the words from this. So what I can do is call regex, and if I say that, then I've got all the word, all the words. So I've basically saying, here's my regular expression. There's 2 backslashes just because we need to like escape the backslash. And so \w in regular expression means any kind of word character, and plus means 1 or more. Now, I'm sure, there we go, that's what I was looking for. There's numerical data in there, and I'm going to get rid of that. I'm going to say I'm only interested in alphabetic. So I'm going to go A to Z. Capital A to lowercase z means it will get both upper and lowercase, and there we go. That just shortened that a little bit. And so if I pop that in there, then that's what we've got. And I can say words equals that, right? Okay, what about reading numbers? So if I read, well, I could take file read as string. I have a file with numbers in it. Oops. Let's just have a look at what's in there. So it's not only numbers, it's a bit of text as well. There's 3 number sets from random.org, set 1, set 2, and set 3. And so what I'm going to do is I'm going to use the regular expression 0 to 9 plus. And I need to actually see that. So what we get here, you can see there are boxes. There were boxes in the words before, I should have pointed out. All right, there are boxes in the words because the words are all different lengths. So they have to be boxed, right? And the numbers, now that's just reading text at the moment. It's not reading numerical data, it's reading textual data. And so we want to parse it. And what I can do is say each parse. So parse is built in, it'll read a string and give you a number. Okay, but before I do that, I should point out we haven't got any negative numbers in here. If I put a minus there, now I get only the negative numbers. But if I put a question mark after that, then that means that the minus sign is optional. And so now I've got all of the numbers, and if I go back and do the parsing, then now I've got what I want. Now, the astute among you will notice that there are some numbers here that don't really belong, like set 1. Like, I probably don't really want the 1 there, or the 2 or the 3, right? They're not really part of my number sets, but I'm only doing this just to get some numbers to play with, so I'm not going to worry about that. Okay, so that's reading data from a file, and you could see the role of boxing in there. Okay, now we're going to sort some data up and down. We're going to sort. So if obviously I start with the numbers here. Now, does Uiua have a built-in sort thing? No, it doesn't. It does have a primitive that's related to sorting, but you have to apply it. So if I take the numbers, right, and if I call the function rise, then looking at that by itself won't mean much. So if I take a copy so that we can look at both, what I'm actually going to do is just this once, I'm going to cheat a bit, just so we can see a little bit of separation, right? So if we look at the numbers and we look at a rise of the numbers, what does that mean? These are indices into that array, so that they've got the same length, right? Everything here has its index in here somewhere. And what it means is it's given us the index in sorted order. So index number 63 of numbers is the smallest number. Let's see, I'll go pick, no, is it pick? Let me try. No, I don't think that will be pick 63 numbers. Okay, yeah, -20 is the smallest number, right? And then the next index is 20. So if I say pick 20 numbers, then that's -19, right? And then, so hopefully you get the idea, right? These are indices of a sorted array. And if you have the indices of the sorted array, then I can call select and, oops. Right, so I've got my numbers. I'll call rise on a copy of it. And if I call select, then there we go. I've got numbers now in sorted order. And if I change rise to fall, then we get them in reverse order. Okay, so the idiom then, so if you've got the numbers, the idiom to do sorting is to do select rise dot. Oops. There we go. All right, and it's an idiom and with no spaces, so you come to recognize that. People who are good at array languages and have an affinity with array languages that have all these hieroglyphics in them, they like to point out correctly that in a normal language, if you want to sort something, then you write 4 characters. Here you just write 3. Okay, so that's like a justification for not having a named sort function, right? It only takes you 3 characters to spell the idea of sorting. There's a certain idea here that this is more flexible as well. You can kind of do a rise on one array, but then select from another, which means that you're gaining more flexibility in how you sort, which we're going to see in a moment. Okay, so we've seen sorting numbers up and down. Let's have a look at sorting the words up and down. So here's my words, and if I apply the idiom, so select, rise, and dot, then I get the words in alphabetical order. Notice that uppercase characters sort before lowercase characters in every computer language, because that's the way it is in the ASCII and Unicode encodings. And I won't bother doing the fall. Now, what about find minimum and maximum? That's next here. So if I, no, actually, did I want to do this a different way? No, it says sort words by length 2 ways. I'll wait for that. Okay, so minimum and maximum. Well, let's go back to the numbers. How do you get the minimum number out of here? Now that we've sorted it, you could just say, well, give me the first number, right? So that would be a way to get the minimum, but that's an expensive way to get a minimum. If sorting is order n log n and getting a minimum should only be order n. All right, if you think of an early programming exercise to find the minimum value in a list, you go through the list once and you keep track of what the minimum so far is as you go, and then you get that at the end. So all we need here is actually a reduced minimum, and that gives us, so that's order n rather than order n log n. Reduce probably most people watching the video have an idea of what reduce is. I'd just like to maybe give myself a chance to, or give you a chance if you don't know it. Let's say I have a list of 4 things and I want to reduce it with plus, right? So that will give me the sum of the whole lot. What reduce really does is it looks at the first 2 things and adds them together. So 4 and -2 is 2, and then you've still got the rest of the thing untouched. And now it'll look at 2 and 7, and if you call reduce plus on that, then you've now got 9 and 9, and now you've got that, and now you've run out a list, and so you've got 18. Okay, so reduce literally means go through the list once, looking at things 2 at a time, and keeping track of the result until you get it down to 1 item. So you're reducing a list of things down to 1 thing. If you reduce with minimum, 4 and -2 have a minimum of -2, and there's still 7 and 9 to be considered. -2 and 7 have a minimum of -2, and there's still 9 to be considered, and -2 and 9 have a minimum of -2, and there's nothing more to be considered, so that means the minimum of that list is -2. So that's what reduce does. Okay, reduce minimum, and if I say reduce maximum, so there we go, we get 20. Okay, so just 1 sec. Okay, now my next thing is to sort numbers by absolute value. Right, so we want to sort the numbers by something else. So if we look at the numbers, you can see that there's minimum and maximum in there, but let's sort them by absolute value. So I've noticed I'm going to do this probably maybe 2 ways. The first would be, let's say, what happens if we calculate the absolute value? So there we go, we don't have any negative signs. Let's do the absolute value of a copy so that we can still have access to the original numbers. And now if I do a rise on the absolute values, okay, there's a rise on the absolute values, right? But if I don't keep the absolute values lying around, if I just do a rise on the absolute values, they've now been consumed, and now I've got indices that I can apply to the original, and I can do it straight away because the stack is in the way it needs to be. I've got the indices at the top of the stack, and I've got the numbers below that. Notice, of course, what's on the bottom is called the top of the stack, right? I actually just like to think of it, because I like coding down the page, at least when I'm developing something, then I like how coding down the page mirrors like the stack going down, right? So I don't really necessarily think of it as the top of the stack. Anyway, and there we go. The numbers are now sorted by their absolute value. And it's interesting, we've got the 1s and the negative 1s mixed in here, and the negative 2s and the 2s mixed in here, right? So things are a bit mixed up, but within each group, like the groups are sorted in the right order. And so this is actually really similar. So if I do my normal idiom, select rise dot, then I get the numbers in order. All I have to do is put an absolute value in there, and now they're sorted by absolute value. Okay, so very cool. And so there's a reason why we don't have a sort function, right? Because by using the primitives, we gain flexibility, and so that's very nice. And if I were to sort the words by length, then that should be pretty obvious now that I'm going to go select rise length dot, and okay, so something went a bit wrong, didn't it? So let's have it. Might need to play this out a bit better. Okay, so if I go the length dot, right? Interesting that it's the it's the, okay, let me get rid of this. Okay, I thought this was going to be easy, but I stumbled over something. Okay, so right, if I go length, then that gives me how many words there are. Well, that's not what I want. I want each length. Oops. Okay, so that gives me the length of all of the words, right? And if I put a dot in there, okay, so I've got each length. And now I can do the rise, and now I can do the select, and we're good. Okay, so it's put the short words here and the long words here. All right, so we're all good. So let me try that again with select, rise, each, length, dot, and we're good, right? Now, you might think, you probably don't, but I'm just going to point out, like, do we need brackets there, right? So, and it's funny it gave us a different answer there. So I'm not going to go into that. I'm not going to analyze it. But the point is, we don't need brackets there because each length is actually parsed as like a single unit. That's because each is a modifier that affects how this function behaves. That's one way of putting it. My preferred way is to think it's a higher order function, right? So that each uses the function length and then operates on the next thing on the stack. Okay, so we've sorted the words, and if I obviously if I change this to a fall, then we're going backwards. Okay, so that's one way to sort of words by length, and that's a very good way. Now I'm going to show you a different way, which is not going to be better, but could be more flexible, and it's definitely interesting. So if I have the words, right, so here they are in no particular, well, certainly not in length or alphabetical order. They're in story order. If I have the words, what I'm going to do is I'm going to calculate the length, right, of each, right? Yeah, and keep a copy lying. Oops. Right, so I've got a copy. What I'm going to do now, I'm going to join these two arrays together. Can I just call join? No, that doesn't give me the result I want. I'm not going to analyze that. What I need to do is call maybe each join or row join. I'm going to go row join, and that gives me what I want. So I now have quite a matrix, and each word is now paired with its length. Right, now there's no particular order, right? I imagine it, like I think it should be the same order that it was in. It looks like it was in the same order it occurred in the story, which is exactly what it should be. Okay, but anyway, I've now got things paired together, and when things are paired together, you can operate on them. And in particular, I can now do a sort. I can do an absolutely plain sort. I just go select, rise dot. Oh, okay. That did work. It's just that because my screen here was scrolled up. Okay, so let me start again just for effect. Right, so I have the words, and I do the each length, right, and I do work on a copy, and I do row join to make a nice matrix, and now I just sort that matrix using the sorting idiom that I know, select, rise, dot. And now the matrix is sorted, and because it's sorted, it's like looking at each pair, and it's putting because the number comes on the left, that's the first thing that gets looked at. Now there's something really interesting here. Amongst all of the ones, these are now sorted in alphabetical order. Amongst all the twos, these are sorted in alphabetical order. That's not something that would have happened if I did it the other way. Right? We saw with the numbers, when I sorted by absolute value, there was a lot of mixing of values, but these get sorted in alphabetical order amongst all the sixes, then the sevens, then the eights, right? So very cool. But now I don't want these. These are an implementation detail that just helped me to get the result. So how do I actually get the result? Well, I can drop. If I drop the first column, there's probably a way in Uiua to just drop the first column. I don't know it. So I'm going to call row, and then I'm going to say drop 1. Now, what I do here is not going to work. Okay, that just simply doesn't work. What I need to do is use brackets. So row, and then I need to put drop 1 in brackets, because row is a modifier or a higher order function. It's looking for a function to apply to every row, and I need to apply the function drop 1. All right, that's why the brackets are needed, to group those together. Brackets, round brackets, parentheses in Uiua actually create an inline function. Now drop needs 2 values, right? And I'm only giving it 1. So there's an automatic thing going on that in other languages would be called currying, where if you give it 1 argument, like this says drop 1, but it doesn't say drop 1 from what? Well, it works very nicely to drop 1 from each row. And here we go. All right, so I've now got just the words, but they're now in like a column matrix instead of just an array. If I do a shape on this, then I get 124 rows and 1 column. So if I think it's called D shape, there we go, I get them in a list. And look at that, it's a musical flat because we've flattened the array. That is so cute. Okay, so there we go. I've sort words by length. I've achieved that. I've done it in 2 ways. Is one of them better than the other? Well, this one, as pointed out, not only sorts them by length, but it applies a secondary sort by alphabet. So this is kind of like working in a spreadsheet where you've got a table and then you add a column to the table and you do some calculation, and you use that calculation to do some filtering or some ordering, and then you might even get rid of that column because it's no longer needed. Okay, so that's very cool. Okay, what's next? Put numbers in a matrix and sort by sum. Okay, so here's my numbers. I'm going to put them in a matrix. This is like 101 of array languages, but I haven't done it yet. So I'm going to reshape in, let's say, a 6x4 matrix. So I've got a 6x4 matrix using those numbers, only 24 of them. It's just truncated. If I do, there's about 90 odd numbers there. So if I did a 10x10 matrix, then it would actually have some repetition. So can you see, there we go, 1, 19, negative 14, and here's our 1, 19, negative 14, and so on. Okay, so we can make a matrix. I think I'll go to say 7x5 matrix. And actually, just while I'm at it, you're not limited to 2 dimensions, of course, right? Now, 3 and 4 dimensional matrices are far more than I need. I'm really pleased about that. But anyway, here's a 7x5 matrix. And what do we want to do here? We want to sort the rows by the sum. So that would mean, how do we sort by? Well, we calculate the thing that we want. So we go row, and then we could do a sum, which is a plus reduce, and we're going to keep the copy. So there they are. And then I'm going to, now we can just see here that the first one, 1 plus 19, 20, so we're up to now 6, and then add 13 is 19, and then take away 15 is 4, and that's what gives us the 4 there, okay? And then this one adds up to 0, and this one adds up to 17. And now I just do the select rise dot. Okay, that didn't work because I just did it too quickly without thinking. I think, yeah, I don't want the dot, that's why. And then select. Okay, so those are now sorted by sum. We don't know what the sum is, but it's sorted by sum. Right, what's next? minimum number by absolute value. All right, so if we want the minimum number by absolute value, then we can we can just take the first of the sorted. Oh, sorry, that's not by absolute value. So if I insert an abs in here, right, then now this line is sorting by absolute value, and then this line's taking the first. Okay, so we're going to do better than that, and this one's not going to be super easy. So we're going to do a minimum reduce on a copy. And so -20, right, is the minimum. But I haven't done the by absolute value. Right, what am I going to do? Right, I'm going to do. Each. No, I'm going to. Right, if I do absolute value. Okay, and now I'm going to maybe take a minimum of that. So the minimum is 0. Okay, I'm being caught out a little unprepared here. I've done all this before, but it's not coming to me now, and it's not going to come to me on a live, on a video recording. Okay, a minimum number by absolute value. All right, not what I wanted, but I'm going to actually skip ahead and show you how you can create a minimum by function. Right, so this is right. If I'm going to pick the index of a minimum reduction of the rows of the given function of a copy. Okay. Now, I can now take the numbers, there we go, and I can say min by, and then the absolute value, right? And I get the 0. Okay, so this is, now you've seen me create functions before. This is creating a modifier, right? A modifier needs to end in an exclamation mark, and in this case it has to end in one exclamation mark because it takes one argument, and that argument has to be a function. Right, so just like when you call, row, plus scan, plus reduce, then the row is a modifier. This is a modifier as well. Let me say row length. That's easier. You've got a you got the numbers, and you say reshape into 6x3, and you do a row length, then obviously each one is three numbers long, right? The point being, row is a modifier that modifies how length works, or as I prefer to think of it, it's a higher order function that takes length as a function and then does its thing on the data. So min by, so if row didn't exist, then we could create it like this somehow, right? So creating min by here is called a custom modifier, and we've seen here, we've seen here that it works. Now let's just pick it apart a little bit. So if I play that out bit by bit, if I start with numbers, now the _1 is the function. So if I take the absolute value dot, then I get that. And then if I apply the if I apply the minimum reduction, then I get that. And now if I do an index of then it tells me 17, and then if I do the and then I do a pick, no, not pick. It's interesting. I'm doing the same thing as I did here, and it didn't like it. Okay. All right. Well, apologies for this mess. I'm just going to move on. Okay. Maybe minimum word by length. Well, I've got my min by thing. I can say words and then min by and then length. Right. And there we go. I get a 1-letter word. All right. And so now we'll get into advent of code. Just a brief look at the 2018 day 1. So if I'm going to read from a file, right, so I'm going to just introduce, I did my words and numbers here. I'm going to maybe say, I might just take this and I'm going to call it read ints. And if I get rid of that last thing, then I've now got a function, right? And I'm going to say data equals read ints from a file I have, which is AOC 2018 data01.txt. Now, this is not going to be, this runs, but it's not going to be great. Let's have a look why. It actually is going to accidentally work. Let me just show you what I'm talking about. So if I data 01 text, all of the numbers have either a plus or a minus, okay? And my regular expression is ignoring the plus, but it's taking the 1 and the 2, and then it's parsing that to get 12, which of course is fine. My regular expression is picking up the negative, and it's parsing that to get negative 18, and of course that's fine. So no harm, no foul, but I'm going to just change this to allow a plus or a minus optionally, right? And it won't make any difference to the data. It'll parse it the same, but you know, I just like my regular expression to be a bit more general. Okay, so I've got the data, right? The length of the data is 1004, so I've got a lot of data to work with, and so part 1 is simply a plus scan of the data. Okay, so that's the correct answer for my data, 587. Part 2, I have a way that I've approached it, which will be the subject of the next video. It took me a long time to get it to work. First of all, it took me a long time to find the approach and to get it to work. Doing this in Uiua is not the same as doing it in other languages. I'd just like to flick back here and mention this. So I got the inspiration for tackling this problem from this YouTube video that you can search, and I encourage you to do so. Dialogue, webinar, advent of code. It's an hour and a half or so, very interesting. I've mentioned before, dialogue is the like the principal implementation of the language APL, which has similarity to Uiua, and someone, I think it was the CEO of Dialogue, did a webinar looking at some advent of code problems in APL. Very interesting. I'm not that inspired to try APL myself, but I do like seeing people work with it. And he tackled this one, but he didn't tackle it in a completely general way. So what we need is, you can see if that's a bit of example data, then that generates the following frequencies. Starting at 0, we keep adding and subtracting as necessary, but we have to keep going. Within the first round, there's no repeats, right? And then we go, start at 4, take away 6, negative 2, add 3, get 1, add 8, and so on. So here's our next 5 values, and here's our next 5 values, and there we go. We've got a repeat, okay? And so the answer here is 5. So rather than using the actual data, I'm going to just override my data. And what am I going to do? I do -6, oops, 3, 8, 5, and -6 again. And what we need is to like cycle that data a number of times and then take what's called a scan. If I do a backslash instead of a forward slash, then I get cannot add character and character. Wonder what I did wrong there. Let me just because data's not on the stack. Silly me. Okay, I've defined it, but it's not on the stack. So it was using part 2 was on the stack, and so this was reaching back and okay, there we go. So here's our actual input data, and here's a plus scan. So -6, -3, 5, 10, 4 is what we see here. -6, -3, 5, 10, 4, right? So a cumulative sum. It's like reduce, but we keep all of the intermediate values. Okay, now what we need is to get a much bigger thing, but I don't know how long it needs to be. So something we can do is we can keep, let's say 10 copies of it, right? Or 100 copies of it, right? So we can, so this function keep is has a couple of uses, but here we're really just making copies of it. Another way to do it is to say reshape, silly me. You've seen me reshape, let's say into a 2x2 matrix, right? Well, what about reshaping into a, let's say, just a 40 matrix? There we go. Not a matrix, an array. Okay, so you can use reshape to create copies, right? At this time, it's not going to be an integer number of copies. It's going to be like just at whatever length you like, and using repetition to achieve that. All right. So anyway, I think I'll do the keep approach. So let's say keep 20 versions of our data, and now we will do a plus scan of that. All right. So, and now we're looking for repetitions, and you can see there's a 5 there and there's a 5 there. Now there's a couple of approaches here. So I'm not going to do stack based here. I'm going to, let me say, okay, so I'm going to give this a name. And now if I say, let's say if I say index of, let's just say 5 in X, then that's 2, right? So if I put X there, oops. Right, so here's my X, and the index of 5 is 2. It's right there, 0, 1, 2, right? But you're not limited to one value. If I say index of, say, 5, 1, 13, you can see there's a 5 there, and there's a 1 there, and there's a 13 there. Then I'm told 2, 6, and 12. There's your 2, there's your 6, and there's index 12, right? So a cool thing I can do is get the index of X and X. And now, wow. So it's like the index of -6 in here is 0, and the index of -3 in here is 1. The index of 5 is 2, the index of 10 is 3, and then 4, 5, 6, 7, 8, 9, 10. Oh, but then that one doesn't say 11. That one says 2. That's because if we look 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, hello. The index of 5 in this array is actually 2. So we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, and that is the clue that we've got a repetition, something that's occurred earlier. And so what we really want to do is to, like, let me just ask for the length of this. the length is 100, right? I've taken 20 copies of a 5-element thing. So if I were to, say, do a range of 100, then you can see that it bears a striking similarity. We've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, whereas this had 0, 9, 10, 2. And so it's where they differ that matters. So I've got these two things on the stack, and if I want to know where they differ, then I can just say not equal to, right? And so that 1 is an indication that the things in that position were not equal, right? And I'd like to know where does that 1 occur. And so this gives me, now I'll take a dot so we can see both. So here's my Boolean array of 0s and 1s, and this gives me the indices of all of the 1s. And all I really want is the first one, and that gives me 11. And now I want I want to pick that value from the data. So okay, well, if I go pick 11 from the data, x, I mean. Okay, pick 11 from x, and that gives me the value 5. Okay, so this is a bit of a mess, but all the ingredients are there. If I do, okay, create a nice little separator for myself. All right, so I've got my data. I'm now going to try to do all this without any variables, apart from data, of course. So I'm going to take a plus scan of keep 20 data, just like I had before. And now I'm going to do an index into itself. So I'm going to take a dot. So now there's two things on the stack, and I can call index of, and I get that thing that I had before, right? But I need another copy of data lying around. So there we go, another dot. Okay, so I've done my index of, and now I need to take 100, but not take 100. I need to get the length of that without destroying the stack. So I've got 100, and I need to range. I always get range and take mixed up. It's so annoying. Okay, get a range from, okay, so I've got 0 to 99. And now what do I want to do? I want to compare these two with a not equal. So, so that's not equal. All right, so I've got my Boolean array. And now I need to do a where. I don't need to keep the Boolean array, so I'll just go where, not where dot. And now I need to get the 11 and get the first one as an index into there. So I can say first. Now I've just got the 11, and now I can do pick, because it'll be going pick 11 into there. So there we go, and that'll give the answer 5. So let's try tidying this up. Solution equals. So the data will be an input. So we're going to do a plus. We'll do a plus scan of keep 20 of it, and what I can do here is go solution data, just to get a, like a running check that we're doing it okay. On that formatter, I'm not happy about that, the formatter collapsing that, but looks like I'm just going to have to accept it. Okay, and now what? Looking up above, all right, dot, and do an index of. Okay, good. It's not reformatting it now. And then I'm going to do the range length dot, and then I'll do the not equals, and I just want the index of the not equals, and I'll get the first of those and I'll do the pick. And something, and that's because, that's interesting. Okay, that worked. Well, it didn't actually work. All right, okay, so far I've got my, my range thing, and now I need to do the not equals, and then I need to do the index of, and the first, and the pick. Interesting. Isn't that interesting? You're probably screaming at the screen going, "What? Should have noticed something." Oh, I didn't do a where. That's right. Okay. Right, so I've got my thing right. I need the where, and the first. Yeah, this is going to work. Okay. Whoops. And I'm going to put that on one line. Okay. So, you know, like a more experienced programmer would probably just put this all on one line. I like to think, I like to break lines. I like to think of when am I putting something on the stack and when am I manipulating what's already on the stack and so on. I don't think it through in a completely formulaic way. It's just kind of intuitive, and I'm not saying anyone should copy me. Everything we're doing here is like stepping stones to getting better at the language. Okay, I think I'll call it there, and yeah, hope you enjoyed.